Hello, 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 ladies and gentlemen. Welcome to another edition of Faith Unaltered. I'm your host, David Russell, and I am joined with my co-host, the man, the myth, the legend, stay like Christ guy, Tyler Fowler.
Dale
What's up, brother?
Glover. No, what's up? What's up, David? I'm doing good, brother. I'm excited to be here with our guest, Tom. Excited to talk about his book. And yeah, it's been a fun week. So I'm ready for the weekend, ready to fellowship with y'all. Let's do it.
Yes, I'm also joined here, guys, with one of my favorite people from Canada. Well, the only Canadian that I'm friends with, really. But Dale Glover, what's up, buddy?
Hey, David. I'm doing great. Glad to be here. We just did our show last night on my channel with Phil Bear, so I'm glad to switch things around. Now I'm on your show today.
Yes, it's actually a welcome change. I didn't think we'd have you on today, so I'm glad that you're here. It's always good to get your input and your thoughts on things as well. Well, guys, we have a very special guest here tonight. He wrote a book that we wanted to interview him on called God, the Geometer. So I am going to introduce Dr. Thomas McAvoy. How you doing, Thomas? Or Tom? However you want me to say it. Got to unmute your mic, bud.
All right.
That was my fault. Sorry.
Well, it's nice to be here.
Yep. So Tom, tell us a little bit about what you do and who you are and, about the book that you wrote.
Sure. I'm currently Professor Emeritus in the Department of Chemical and Biomolecular Engineering at the University of Maryland. I taught chemical engineering for just under 40 years. First at the University of Massachusetts, 16 years, and then at the University of Maryland for 24 years. And the book really started almost 20 years ago, or maybe a little bit more than 20 years ago. I'd been married for 41 years, and my wife contracted a very rare cancer, pseudomyxoma. It's really a very debilitating disease. You wind up getting these very large mucinous tumors in your peritoneal cavity, and you basically get crushed from the inside out. When she was operated on, I think the tumor they took out weighed something like 15 pounds.
Jeez.
And it's just an insidious disease. And she passed in 2004 in June. And I began to ask Job's question, basically, why do these things exist in our world? Why are they there at all? Mm-hmm. So in the fall of 2004, there was a weekly series on Paul's epistles in my parish, and it was run by a guy that had tremendous credentials, our deacon, and he taught computer science, but he had certificates in theology and like 4 or 5 different either certificates or degrees. And so I was interested in that. And actually at the same time, I also started a research program on the disease. There was almost nothing known about it, which was very frustrating. You couldn't get any information. And amazingly, that research is still going on today. We published 5 papers on it and verified a hypothesis that there's a bacterial component to it. And also that fall, while I was still grieving from the loss of Jesse, and I'll come back to this later on, but there was a gigantic tsunami that took place in Indonesia and in that area, and something like 180,000 people died and 30,000 were missing from it. It was a huge tsunami. And the question comes, why do these things exist? So I started studying scripture and studying science. And the book is really the result of the 20 years that I put in studying various aspects of science and trying to answer that question as to why these sorts of things exist in our world. So that's an answer to your question, David.
Yeah, absolutely. And we're so sorry about the loss of your love there.
Well, I actually remarried in 2006, and I've been married.
Congratulations.
almost 18 years. So,
Oh, wow.
Good. Yeah, but you never get over a loss like that. Just you're able to deal with it, but it's hard. I lost both my parents, so I lost my mom to cancer in 2021, and it's been hard ever since. Losing her so early. She was only 60. So,
sorry to hear that.
but yeah, it's part of life, and I know she's with the Lord. I mean, I took her down and I went down to go see her and got a lot of closure there. So praise God for that. But yeah, you start asking those questions, and it's one of the reasons that kind of solidified me that and some counsel from some friends, especially like Dale on my thesis was my thesis is going to be on the problem. So it's good to see that you're from Maryland. Are you in Maryland?
Yes, we are. We spend half the time between here and half between Massachusetts.
Nice. I'm a little bit south of you in Virginia, actually.
Okay.
So, yeah, not too far. But yeah, it's good to have you on. I know you got some slides and a presentation that you want to present here. So we're going to let you get started with that. So anytime you're ready, we'll put that up.
Let's see now. I think I click on this and then expand it.
Yep.
And then hit slideshow.
Yep.
All right.
So this is your freedom. This is your time, sir.
Okay. And I guess you guys will have questions. So if you do, just interrupt. I can't see you anymore because of the PowerPoint. But
yeah, we'll probably let you get through the slide and then start with the questions.
Sure.
Yeah.
This is a picture of the cover of the book, and it's called "God the Geometer: How Science Supports Faith." And let me just the reason that I chose this title is I was looking around for a title. Originally, I was thinking of faith and science for the non-scientist or something like that. And there are a lot of books that kind of have titles like that. And I wanted a title that was a little catchier. And I was looking around and I found this image. And let me just read it. I found it in Wikipedia. And the description, it comes from a 13th century codex published between, say, 1220 and 1230. And the description in Wikipedia reads as follows: science, and particularly geometry and astronomy/astrology, was linked directly to the divine for most medieval scholars. The compass in this 13th century image is a symbol of God's act of creation. God has created the universe after geometric and harmonic principles. To seek these principles was therefore to seek and worship God. And I thought, wow, that's perfect. That's exactly what I want to talk about in the book. And it's kind of a unique title in a way. So that's how the title came about. So that's the book. And one of the questions is, who is this book intended for? What's the audience? And what do I hope people will take away from it? So the first group I wrote it for are people who are asking essentially Job's question, people that have loved ones that have, say, cancer or a rare disease of some kind. My son-in-law has recently been dealing with multiple sclerosis and has run into some other issues with the disease. And it's easy to say, why do these things exist? What's the, I don't want to say the purpose of them, but the sort of question that Job raised when he was tempted. The second is, from my perspective, it seems like people are bombarded today by agnostic/atheistic media experts, Hollywood personalities, et cetera, et cetera. And their message is that, science has all the answers. Religion is passé. We don't need religion. We're fine with science. And what I've found over the 20 years that I've been looking at science and religion is the opposite is true. That the more one looks at science, particularly modern science, the more one sees the importance of faith in God. So that was the second group of people, kind of, a general audience out there. And then the third would be my family and my step family. I see that, some of the kids are now off to college. Actually, my oldest granddaughter is 33 years old, but some of the kids are getting out of college. Some are going to enter college. And I think that universities have changed since I started teaching. And there's a lot of indoctrination going on through the universities. And unfortunately, it's not the right message in many cases. And it's not unique to one university, but I think it's endemic to all of them. So these are the people that I wrote the book for. And as I say, the takeaway that I want people to come away with, the main message is modern science strongly supports faith. So I don't know if you have any questions or you want me to just continue on and talk about the topics in the book that I cover.
Yeah, you can continue on. We're going to actually get into the questions at the very end. So we'll start.
Okay.
Yeah.
All right. That sounds great. All right. So these are a list of the topics in the book, the major topics. There are 2 chapters on the Big Bang. And what I'd like to do is, I'm not going to cover everything about the Big Bang, but talk about 2 aspects of it: energy, the energy implications, and fine tuning. I don't know how much your audience knows about the Big Bang, but it's an amazing story. And then the second is our solar system. And I think a smaller number of people know about the fine tuning in our solar system, how fine tuned it is for life. Then I've got 3 chapters dealing with evolution. And then a chapter on quantum physics and free will. And I think very few people know about quantum physics today. And so I'll get into that. And I've got a few slides on that. And then there's a chapter on natural evil, which was really the problem that I set out to look at. Why do these miserable diseases that we see in the world, why do they exist? And then I have a couple of chapters that deal with miracles, and I've got one slide on that, and I'll talk about that. The miracles that I look at are miracles where there actually is hard data to assess them. It's not like, we'll read in the Gospels of all the miracles that Christ performed, but then if you go back and you say, okay, is there any physical evidence? It's hard to go back 2,000 years and have physical evidence. But the miracles that I'm talking about, there is physical evidence for it. So I've got chapters on that and then a conclusion. So with that, let's talk about the Big Bang. And this is kind of a, it's in a sense a little bit of a gruesome slide, but it's a way to make a point about energy. This is a picture of Nagasaki after the atomic bomb was dropped in World War II. And you can see the total devastation that the bomb caused. Now, the bomb had 14 pounds of plutonium in it. And can you see the penny that I'm holding up? I'll move
Yes.
Camera.
Yep.
I'll turn it around there. It's close to the camera.
Yeah.
It turns out that of the 14 pounds, less than 1 gram was converted to energy. And that's about a third of the size of a penny. So if you take a penny and you take a third of it, that much mass of plutonium was converted to energy in that atomic explosion. And look at the damage that it did.
Oh, my goodness.
And this is one of the aspects of the Big Bang that to me absolutely amazes me. The amount of energy that was involved in the Big Bang is the closest thing to infinity that I can think of. Now, with the Big Bang, when it happened, there wasn't any material present. There wasn't any matter present. There was only energy. Okay, so the Big Bang started with a humongous amount of energy, unbelievable amount of energy. And I'll try to bring that out in this slide and the next slide. And, you can say, well, how does that work? And considering Nagasaki, This is Einstein's famous equation, E equals mc squared. And this was published in 1905. And if you look at it, the amount of mass that was converted to energy in Nagasaki was tiny. So how did you get all the energy? Well, it turns out that this equation says that you take the mass and you multiply it by the speed of light squared. And light moves at an enormous speed, 186,000 miles a second. So when you take that number and square it, you only need a tiny amount of mass to convert to energy to get the effect that was shown in the previous slide. So a little bit of mass, if you can get the energy out of it, would transform into a tremendous amount of energy. But the reverse is true, that mass, if you want to produce mass, and mass is obviously necessary for life and for the universe, you're going to need an enormous amount of energy to get any kind of mass, because the energy has to be divided by c squared. So, for example, I was thinking of myself. I weighed just a little bit less than 200 pounds. So if the energy that is inherent in the mass in my body could be released, it would be 90,000 times more powerful than the energy that was released in the bomb that fell in World War II on Nagasaki. So there's enough energy in my body, if it could be released, that I could probably, blow up the state of Maryland. I may be able to take out a good part of Virginia and maybe West Virginia. Now, once you get stable molecules and stable atoms like calcium and oxygen and nitrogen and whatnot, you can't recover the energy from it. But to make those molecules in the first place, you needed that energy. So the energy to make me was enormous. Now look around and look at all of the material that you see around you. I mean, I live in a condo, so I don't know what the mass of the condo is, but there's probably enough energy, or if you could get it, that it could blow up the whole planet. Okay, so the energy implications are interesting in terms of the Big Bang. So let's look at it. The Big Bang happened roughly 13.8 billion years ago. And I've got ex nihilo creation in green there. And the reason for that is, I think this is the biggest sticking point with scientists that are either agnostic or atheists. They don't like the fact that this appears to be a creation from nothing, that prior to the Big Bang, there was nothing, and then boom, the Big Bang occurred, and now the universe starts. And so look for ways around the Big Bang, and I'll talk about that on the next slide. But this is exactly what Genesis tells us, that, God created the universe from nothing. Now, the time scales in the Big Bang are fascinating. 13.8 billion years is the age of the universe. After about 20 minutes, the Big Bang fusion, which involved converting energy to mass using Einstein's relativity equation, I mean, that's how the conversion, or if you wanted to calculate it, takes place, stopped. So basically, you start out with a tremendous amount of energy. The temperatures were enormous, and the universe starts to expand. And then you get subatomic particles forming first, and then these are transformed into atomic particles, protons, neutrons, electrons, there are neutrinos, and it's a gigantic plasma at enormous temperatures, with these things just banging into one another at unbelievable energies. And then it stops after 20 minutes. And people have modeled this, and whether it's 20 or 25 or 18, it's just a tiny amount of time given the timescales that we're talking about. And now all of the mass, essentially, that's in the universe was created. It wasn't calcium, it wasn't oxygen, it wasn't nitrogen. What it was hydrogen ions, or the protons, actually, and helium nuclei. Things were so hot that molecules couldn't form at that point. But 75% of what was formed were protons, and 25% was helium. There were also electrons. Electrons don't weigh very much that were there, and neutrinos. And in that 20 minutes, all of the mass in the universe essentially was created. So if you look around at our planet, at how much mass there is, and then you look at our solar system, at our neighboring planets, at our sun, and then look at our galaxy, which has an enormous number of stars, and then you look at all of the galaxies in the universe and think of how much mass is present. The amount of energy to make that mass is, as I say, the closest thing in my mind to infinity. And what we see in terms of mass is only 5% of the universe. There's dark energy and dark matter that add up to 95%. So when we go back and we calculate the amount of energy that was present at the time of the Big Bang, it blows my mind as to how much it was. It's just unbelievable. And one of the things about the Big Bang, and people that are religious and people that are agnostic, scientists will agree to this pretty much, without unbelievable fine tuning, we're going to be in trouble. And there are at least 10 constants that have to be superbly finely tuned in order for life to exist downstream. If they're not, one of the things that happens is that you would get all protons. So that would be the H plus here. Let's see if I can I guess I can put the arrow on that. So you get all protons. And if that happens, there's no way to ever make heavier atoms. So there would be no calcium, there'd be no nitrogen, no oxygen, no life. And all it takes is a tiny, tiny tweak for that to happen. Then you come over, and the other possibility is that this fusion of the fusion involves the protons colliding with one another. So you take two of these and they collide, and you can get a helium nucleus. And if that happened to the point where you got all helium nuclei, there'd be no opportunity for life either, because we need hydrogen to make water and to make things like amino acids and whatnot. Now, at the end of the 20 minutes, you wind up with 75% hydrogen nuclei and 25% helium. And that's essentially the composition today of the universe in terms of helium and hydrogen. But the fine tuning is absolutely phenomenal. And this is suggesting that somebody fine-tuned this, namely God. And so these two things together, the fact that there was a creation from nothing and this unbelievable fine-tuning, drives the scientists that don't believe in God crazy. And they want to somehow explain or come up with alternatives to this. Now, going on from the Big Bang, after 20 minutes, this plasma that existed started to cool, and it took almost 400,000 years before it cooled to the point where stable atoms could form. So what happened is that the hydrogen nuclei grabbed an electron, and actually two of them grabbed two electrons and made a hydrogen atom. And then the helium nucleus grabbed two electrons and made a helium atom. Now, there was a very tiny amount of lithium formed, which is the next heaviest element, but it's really tiny. But there was nothing, no heavier atoms at 380,000 years. And if you've read about the cosmic microwave background radiation, which was the measurement made in, I think it was 1992, that validated the Big Bang model, this radiation dates back to this 380,000 time. Before 380,000 years elapsed, the radiation was just banging into the charged particles and the electrons and whatnot. As soon as the stable molecules formed, then the radiation was free to go. And that's what was measured in 1992 to validate the Big Bang. So we get atoms formed, but only helium and hydrogen after 380,000 years. The next amazing piece of the timescale is that it took 100 million years before fusion restarted. And fusion, again, is where you take light atoms and you put them together and you make heavier atoms. So in our sun is fusing hydrogen into helium right now. What happened in these early stars is they were basically all hydrogen and all helium, and the hydrogen fused to helium, and the fusion took place because of gravity. Now, in the Big Bang, as the Big Bang was expanding, after 20 minutes, the hydrogen got far enough apart that it wasn't colliding anymore, and that's why fusion stopped. When stars were formed, gravity compressed the gas, as is done in our sun, and as a result, conditions got to the point where fusion could start up again, and then it could last for millions of years because of gravity holding the stars together. So the first stars formed through gravity, and as they died, once they used up their hydrogen, the helium started to fuse. So helium can then fuse to heavier elements and all the way up the ladder to iron. And when the stars died, these early stars, they expelled these heavier atoms out into the universe. So now the universe was no longer just hydrogen and helium, but there were other things out there. And when the second generation of stars formed, they would bring these heavier atoms into them. And there was also then the opportunity to form planets and whatnot. So that's 100 million years. And I don't want to go over the whole Big Bang, but the question is, where did the carbon come from? Where did the iron come from, et cetera, that we have in our bodies? And I mentioned that these are formed in stars. And one of the interesting atoms is carbon. There were two competing theories back in the 1940s and 50s about the universe. One was that there was a Big Bang, and Alper, as part of his thesis, did the calculations that showed that it was only about 20 minutes before the Big Bang would stop producing helium and hydrogen. But Fred Hoyle was a proponent of the steady state theory of the universe, that the universe had existed forever and it didn't have any start. And but he had to explain carbon because carbon is very abundant in our universe. So he postulated that an excited state of carbon had to exist that had not been measured yet. And he was out at Caltech, and he convinced them to try to measure it. And son of a gun, they did. I think it was around 1957 where they made the measurement. And then that validated the fact that in stars, fusion could take and produce carbon. And then once you got carbon, you could go on up and make oxygen, nitrogen, and whatnot. And then elements that are heavier than iron, as long as you get up to iron, you're actually getting more energy out from fusion than you're putting in. So things are going to go. And the only way to get gold and probably platinum, I haven't checked that on the periodic table, is through supernova explosions, where you get conditions that are strong enough that you can make these atoms. So the story of the fine tuning to get where we are in terms of life is, to me, it's an absolutely amazing story. If you're a pessimist, you'll say that we're made of nuclear waste. And if you're an optimist, you'll say we're made of stardust. So I want to be an optimist. I'm made of stardust. When you take a drink of water, you can realize that the hydrogen in the water probably dates or does date back to 13.8 billion years. The oxygen is much younger because it wasn't made until the first stars started to die. So we can look at the scientists that don't like the story that I just told, and they've come up with stuff like the bouncing universe. So there would be a series of big bangs and big crunches that would go on forever. And then there's the multiverse, and the multiverse is and there are other theories that people have put out. The multiverse is interesting because it basically tries to explain the large number of parameters that have to be finely tuned. And the idea is that if you have almost an infinite number of universes, you're bound to get one that has this fine tuning. So you don't have to worry about the fine tuning. I've often thought it would be interesting if, as a believer, in order for me to have faith in God, I required an almost infinite number of universes, but an atheist only required one. I think they'd laugh the believer off the stage with that type of belief. And yet that's exactly what happens, that, a believer simply says, look, God created the universe. It started with a big bang. And the thing about the multiverse is that there's no way to observe these other universes. They're hypothetical. So what these people are proposing borders on, or is faith, and it's faith that God doesn't exist. In Father Roberts, sorry?
No, go ahead. I just have a couple of follow-up questions, but finish your thought, and then I have a couple of quick follow-ups.
Okay. There's a book by Father Spitzer that was published in 2010. It's called New Proofs for the Existence of God. I found it a difficult book to read, but in there, he discusses a theorem that's been proven, and he lays out 4 conditions that any model of a universe would have to satisfy in order that the universe it describes not have a beginning. It basically, if you look at his conclusion, almost all alternative universes have to have a beginning. They have to have a start, whether it's a multiverse or this bouncing universe type situation. They need to have a beginning. And so he also makes the point that it's pretty easy for theoreticians to postulate models, even though they're very sophisticated models. Ultimately, the proof of any of them would have to be that they agree with what can be measured. And as I say, with the multiverse, there's no way to measure these alternative universes. So that's the Big Bang.
Okay. All right. So I think you were kind of getting into this. Just my first question, you mentioned this theorem. Are you talking about the Borde-Guthun-Vilenkin theorem from the early 21st century, or did you have a different theorem?
It's the one that Spitzer discusses. I'm not sure what the name of it was. He starts out and he discusses all of the fine tuning. And then he's got a follow-up chapter. And in that chapter, he discusses this theorem that would have to apply to any model of the universe and how it was formed. And he lays out the conditions that the model would have to satisfy in order that the universe it describes not have a beginning. So it would have to be then, like, let's say that this bouncing universe went on forever. And he shows that almost all these alternatives have to have a beginning. So this idea that you can have sort of an infinite time scale is ruled out with this theorem.
Yeah.
I'm not sure of the name of it, but as I say, it's not. He's a genius, and it's not easy reading his book.
Yeah. So I guess no question here. I'll just very quickly comment and kind of back you up that what you're saying is exactly right. Like for example, the first theorem is the Hawking-Penrose singularity theorem back in 1970, and that kind of got rid of the bouncing, because even those bouncing universe models, they have to have a beginning. It's been proven. There are only so many times that thing can bounce, because each time it bounces, it's a bigger and bigger expansion with each bounce type thing.
Yeah.
And then I think the one that Spitzer is talking about is the BVG, Board, Guth, and Vilenkin theorem, which says, look, so long as the universe on average is in a state of expansion, and this includes the multiverse, it had to have a beginning. It started at some finite point in the past. So yeah, I back up what you're saying. My only follow-up question before I go to the co-host, on the fine-tuning argument, you mentioned the multiverse counter and kind of refuted that. I'm interested, what's your take? A common objection from a lot of lay atheists and stuff, they'll use the anthropic principle, and they'll say, well, none of this is, none of this fine-tuning is impressive, because that's what we'd expect. We're here, so of course this is what is needed for us to be here. So of course we're observing all this fine-tuning. It's that anthropic principle. What's your response to
that? Well, and I don't know which alternative universe model that they're trying to push, but if you look at just the physical constants and the range of values that they can have, such that you didn't get all hydrogen or all helium, it's unbelievable how finely tuned they have to be. And so you can say, where did that come from? What's the cause of that? We are here, and we can observe this, but I don't think that necessarily means that, for example, that the multiverse is real, or this perpetual inflation is something that, as far as I know, can't be observed either. There may have been an initial period of inflation, but the thing too is that I don't believe that you can use science to prove one way or another that God exists. I think if that were the case, it would have been done. But I think you have to draw conclusions as to what looks reasonable. And when I look at all of the parameters that would have to be adjusted in order to get us here, and what could go wrong, it's like, oh my God, that's to me is amazing. So maybe a non-scientific answer to your question.
Cool. Yeah, I'll open it up. Tyler and David, do you guys have any questions?
Yeah, I've got a follow up. So Dr. McAvoy, you talk as though like the Big Bang Theory happened. Like this is a past event that actually took place in our reality, and basically what got us started. What would you say to Christians who disagreed with that concept, and how, in terms of probability, how certain are we that our modern scientific models of the Big Bang Theory are accurate?
I think they're pretty certain. I don't know what percentage of scientists would agree with the Big Bang, but I think it's well over 90%.
Okay.
One of the predictions that the model that Alper developed in the late 1940s was that there would be this leftover radiation. When the Big Bang happened and we got all the mass that we see, all of the radiation was converted to energy. So that radiation was bouncing around for 380,000 years. And then when the stable molecules formed, the radiation could now just move out into the universe. And the prediction was by Alper that if that were measured, the temperature of it would be something like 5 degrees Kelvin. I forget exactly what they were predicting. It was pretty amazing, though, that they were predicting this in, say, 1948.
Yeah.
Something like that. In 1992, the cosmic background microwave radiation was measured by NASA, and they were coming up with a temperature of something like 3.6 or 7 degrees Kelvin or something like that.
Sure.
Well, that radiation has been measured, and then subsequently, better and better measurements of that radiation have been measured. When if you ever turn on your TV and you have it such that it's not on a channel, you'll hear a buzz. If it's supposed to be on channel 3 and you put it on channel 4, you hear this buzz. That's the cosmic microwave background radiation that exists from the Big Bang. And that's what I think convinced people, once that was measured, that this Big Bang is accurate, and it's the way that the universe formed.
Sure. Thank you. I appreciate that.
Right on, guys. So I guess since we're talking Big Bang cosmology now, I would just want to interject on the eternal cosmological models, such as like the one Sean Carroll presents and Chen, and also the Aguirre-Grayton model, when they are actually dealing now with a reversed era of time. Do you have any ideas on that?
I have not studied those models, so I can't really comment on them. I respect Spitzer. He's an amazing person. He's a absolute first class physicist, but he's also a theologian and a philosopher.
Yeah.
And
so what would you say, since Spitzer is using, because the Borde-Guth-Vilenkin model is the one Spitzer I think is using in his book, and I think that we all understand it's an incompleteness model. The BVG model is. Now Vilenkin and Guth believe in an eternal universe. Vilenkin uses cosmic tunneling, and Guth says, inflation can't be eternally into the past, but the universe could be eternal. We just don't know. So, from what I've studied, I'm an amateur astronomer, so I look into these things quite often, and they seem to be like, it's probably, began to exist, but we're not sure. So do you have any thoughts on that?
Yeah, I think Spitzer makes a good comment where he says, okay, it's pretty easy to come up with mathematical models. The $64 question is, do they describe the universe? And is there a way that you can make measurements that would verify the model? And as far as I know, none of these models have been verified. So you can do things with mathematics, but it's like the Big Bang. The model that Alper and Gamow was his thesis advisor came up with in the late 40s predicted the existence of the cosmic microwave background radiation, and son of a gun, it was measured. So these other models, you'd have to say, okay, what are they predicting, and can we measure that? Or is it just simply, a nice mathematical exercise, but there's no way to validate it? So I think that's the answer. I mean, what are you going to measure that would say, yes, this is a true model? That's been done with the Big Bang model.
Sorry.
Go ahead, Dale.
One other thing, just to back up what Tom is saying here, with these time reversal models of Sean Carroll or Aguirre and stuff like that, it's important to note, even if it's true, if these models are true, let's just grant that for the sake of argument, they still posit a beginning of the universe, because our space-time universe, with our where the direction of time is moving in the forward direction, that's the start of the universe a finite time ago. So even in these models, it's not an eternal model, even if we grant them. So,
well, it's kind of like that divide between classical space-time and then something that was before, but it would be the cause of the universe. It would be the cause of why that. So that's why it would be part of because I mean, if you look at Vilenkin's model with the cosmic tunneling, it pretty much opens into this universe. So yes, this universe would have a somewhat of a beginning, but it's not the beginning that we would think of the philosopher's beginning. You know what I mean?
But then how do you measure? How do you
It's not, you can't, it's
model?
speculative. It's speculative. And like you said, it looks nice with math, but they can't measure it. So like what you're saying is what my defense would have been when I was debating the cosmological arguments. So you
need to validate it somehow. Otherwise you could probably come up, if you're clever, with 10 or 20 interesting models. And and you get a lot of papers and probably get tenure for doing it. So.
And the funny thing is, though, is that doesn't, when we get back to like that time where we have a singularity, I mean, the physics breaks down. So general relativity doesn't really, work anymore there. So we just don't know. And that's what I think a lot of atheists say. Well, we just don't know, know. And so they use that, but then they ignore everything else.
You have to look at the big picture, because Big Bang is one thing. Our solar system is unbelievably fine-tuned also, maybe not quite as fine-tuned as the universe. And then, other aspects of science that say, hey, put the whole thing together, and then what's your conclusion? What makes the most sense?
And I think that's a perfect spot. I know you're getting into the solar system, so I'll let you continue with that. That's
right.
Very interesting.
So let me talk about the solar system, and I've got a chapter on the solar system, and there's a book that I found that is really great. I'll just hold it up here. It's called Rare Earth. It's written by two guys from, I believe, the University of Washington, and the subtitle is "Why Complex Life is Uncommon in the Universe." I think a lot of people look at the universe and they say, "Oh my God, there are billions of stars out there, and billions of planets. There's got to be a whole slew of planets that could harbor intelligent life." And so, if you look at what we have, it kind of really narrows down that possibility. I don't rule out that there are other planets that could have intelligent life on them, but I think that they're going to be few and far between. So I'm going to talk about, I've got slides for the moon and for Jupiter, but let me just quickly go through the others. The Earth's magnetic field is one thing that we have. And this comes from the fact that in the core of the Earth is molten iron. It's kept molten through nuclear reactions. And this generates a magnetic field. And so when cosmic rays come toward the Earth, the magnetic field deflects them. Now, Mars does not have a molten iron core. And so the cosmic rays just stripped away Mars's atmosphere. And that's why it doesn't have an atmosphere. And if you don't have an atmosphere, obviously you're going to have trouble for human life or intelligent life. Plate tectonics is another thing that we have, where you get the continents are floating on the Earth's surface. If we didn't have plate tectonics, if everything was stationary, there's so much water on the Earth that the Earth would be covered with water. But with plate tectonics, the plates move together, they create high land, and then we have the continents where humans can live. They also have a thermostatic effect, like a home heating system, where they can help regulate the temperature of the planet. The global thermostat, I think it's called. If you look at our solar system galactic orbit, it's almost circular. And we move around, and we're at the outer edges of the Milky Way. And we don't get close to the center. And in the center is a black hole, and there's enormous radiation. So things like elliptical galaxies, for example, where solar systems would rotate near the center, are not going to be conducive to life because of the radiation. Our sun is the right kind of a sun in terms of its temperature. We also have an almost circular orbit around our sun, and you can just look at all of these conditions, and this is what they do in the book Rare Earth, and say, wow, there's a lot that has to go right in order for us to exist. Now, I brought a couple of props, but I don't know if you're going to be able to see this or not. It may be too big, but this is a globe, and I think you can see that it turns on an axis. And let me put up the next slide. The Earth looks like this, and it's tilted 23.5 degrees off of the vertical. And the tilt is actually maintained by the gravitational pull of the moon. So we've got a relatively big moon compared to the size of the Earth. And the moon obviously rotates around the Earth, and it stabilizes this axis of rotation. Now, Mars has 2 small moons, and they're not big enough to stabilize its axis of rotation. So what would happen is, if we didn't have the moon, then over time, the axis of rotation would vary. And here I show it'd be a slow situation in all likelihood, but you start with the North Pole up here, and now it rotates down to the equator. And you can think of the effect that would have on life itself, that, life takes time to evolve and to adapt to climate. And if the climate was changing as much as this, then it would be difficult to sustain life in vast regions of our planet. So the moon is really important to us in terms of what we see in the diversity of life all around us. And people can Google life without a moon and just see what would happen. The other thing is Jupiter, and Rare Earth has an interesting discussion on that. This is a slide that shows the relative size of the 8 planets in our solar system. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Uranus, I guess it is, and Neptune. And you can see the size of Jupiter. It's where's my arrow? Right here. It's about over 300 times larger than the Earth. And if I were to show the sun, then we find the Earth is just a little tiny dot. You can hardly see it here in terms of its size. You can see Jupiter. And what Jupiter does is interesting. It acts like a baseball catcher. When asteroids come into the solar system, Jupiter is so big that it attracts them and gobbles them up. And it's not our nearest neighbor, but only Mars is between us and Jupiter. But without Jupiter, whoops, went the wrong way. Without Jupiter, I saw one estimate that we would have been hit with large asteroids much, much more than we have been. About 65 million years ago, there was one that hit the Earth. It wiped out something like 70% of the life on Earth. The dinosaurs went extinct after that. And the estimate I saw was that there'd be something like 10,000 of these that would have hit the Earth if we didn't have Jupiter. Now, fortunately, we're far enough away from both the sun and Jupiter that we're not getting sucked in by their gravity. And yet Jupiter is acting to protect us. So if we didn't have Jupiter, then we probably wouldn't have intelligent life on Earth. There'd probably be no life because of the asteroid collisions. So the point in the chapter that I have on our solar system is that there are so many things that are right about our solar system. And to just simply say, well, there are, millions and millions and millions of planets out there, there's got to be, millions and millions that could have intelligent life. I think there are a lot of conditions that have to be met before you can have the type of environment that we have here on Earth. So that was the material I had on the solar system. I don't know if you guys had questions on that, or I should.
All right, I have a question, just real quick, Dr. McAvoy. Why would you say that the Earth is a globe and not flat? No, I'm just kidding. Go ahead.
I guess because this shows that it's circular.
Fair enough. We got a couple flat earthers that watch Faith Unaltered, so I just had to throw that in there. But no, go ahead. That's good.
I've not heard of the great David Weiss proving the flat Earth, but
the Rocket Man.
So
let's move on. I
Tom,
mentioned that I've got some material on evolution. There are actually 3 chapters. I wasn't going to do a lot of discussion on that. In the evolution chapters, I try to address three questions. One was Stephen Jay Gould's question that basically if evolution could be rerun, he didn't think it would lead to intelligent life. So he was basically saying that evolution is kind of a random event and you wouldn't get intelligent life again. And I've got a discussion in there. Dan Kubler, who's a dean out at Franciscan University, has written some really excellent stuff on that discusses the fact that if you look at evolution, there are patterns in evolution that can be detected, and that it's not a random operation. Now, chance definitely plays a role, but it's not random. Then the next is a criticism of Daniel Dennett, who's an atheist up at, I think it's at Tufts, that there's no purpose of evolution. And I think the purpose of evolution is survival of the fittest. But in the case of humans, that can also lead to cooperative behavior because, we don't have, great speed. We don't have great fangs or great claws or whatnot. We have to cooperate in order to survive. And to me, what religion does is it kind of builds on that because it says that if you have faith, you can basically survive forever. And so I've got a chapter on that. And then I've got a chapter why intelligent design is not science. And in that, basically, it's just with intelligent design, when you get to something involved with evolution that you can't explain right now, then the answer is God must have done it. And as soon as you take that position, that's not a scientific position. That's really a faith position. So intelligent design is not approaching evolution from a scientific point of view, in my opinion. So I don't know if, David, did you have questions on evolution or should we go on?
Yeah, we'll save the rest to the end because I know you're almost done with the presentation. I know you got just a little bit more.
Now, the next part I think is kind of fun for me. And, my background is engineering. So I'm not a chemist. I'm not a physicist. I'm not a biologist or microbiologist. But I've done a lot of reading on the subject. So I've got two chapters on quantum physics and free will and freedom and natural evil. And so we'll start with quantum physics and free will. And the quantum physics, in my opinion, and in the opinion of some other people that I've read, provides a physical basis for free will. And I'll get into what I mean by that. Now, Feynman, who's a Nobel laureate physicist, has a great quote. He says, "Nobody understands quantum mechanics." And after reading it, reading up on the subject and whatnot, I can absolutely agree with him. It's the strangest subject that I've run into. It applies to very, very small entities. It actually applies to everything. But you only can really see it when you're looking at very small entities. So things like photons, electrons, molecules. As I say, it applies to macroscopic objects, but what you would see, the differences would be you can't measure them. They're so small. And as far as I know, no quantum physics prediction has proven wrong to date. It's been an extremely successful theory. The discussion in my book is based on another book I'll hold up. It's Ken Miller's Finding Darwin's God. And this is a great book. Miller is a biologist at Brown University. And he's interested obviously in evolution. He's got some great insights in evolution. But he also talks about quantum mechanics in the book. And I've quoted him pretty extensively in my book with his permission. And that's a fabulous book that I think was a bestseller when it was written back around 1999. So I want to give an example of that from quantum mechanics that is a classic example. Here's an experiment that you could do where you take a laser and you shine it in, and there are two slits here through this screen. And you have, let's say this is a detector screen. It could be a photographic film. And then this is the detector screen that's turned sideways so you can see what the screen is measuring. And so the light comes in, goes through the two slits, and it acts like a wave. This is like if you were to throw a stone into the water and you get waves rippling out. You see the dark and light regions here from the spreading out of the wave. You can run another experiment where instead of putting a wave in, you put particles in. You fire particles towards these two slits. They're big enough that they can go through. And this would show the experiment partway through. If you did it enough, you'd see two horizontal black lines over here on this side, and then everything else would be blank. So kind of two different experiments that you could think of running, one with a wave and one with particles. So now we're going to modify the first one, and we're going to put in a way of measuring what's coming through the slits, a photometer. And we have the laser light going through, and now we're going to measure it. And as soon as we do that, all of a sudden, the pattern changes. And over here now, if I can find my arrow, over here we have, this is now the laser wave, the light wave coming in, but it behaves as if it's a particle. And you say, what the heck is going on? I go back here, have the light wave going in, and it looks like a wave. And it's measured that way with the photographic plate. Put the measurement device in, all of a sudden the light changes its character. And now the light is behaving like a particle. And the amazing thing is that light acts both as a wave and as a particle. And it's like, what's going on here? Now, one of the books, and I don't have my copy, I left it up in Massachusetts, that I recently read. It's a fabulous book. It's by Michael Gillen. I don't know if you're familiar with it, called Believing is Seeing. Gillen is an interesting personality. He's has 3 PhDs from Cornell, a PhD in mathematics, a PhD in physics, which was really quantum physics, and a PhD in astronomy. He was also a television personality. He was the science editor, I think it was for ABC. He's written several books. And in Believing is Seeing, he talks extensively about quantum mechanics. And his insights are really, I think, neat. He says, okay, the Old Testament is pretty logical. And he explains it this way. He says, okay, the Jews screwed up. They were punished. They repented. They got back in God's good graces. And then it started again. The Jews screwed up. They repented. They, blah, blah, blah. And it's just a repetition of that. It's very logical. And then he says the New Testament is translogical. And what he means by that is that it has some statements that you just say, wow, what does that mean? Like the last shall be first. And the premier example would be Christ being both man and both God at the same time. And he likens that to light. He has a tremendous section on light. God is light. Light is both a particle and both a wave. And to him, what he found in his study of quantum mechanics, the translogical aspects of it, correlated perfectly with what he read in the New Testament. And as I say, it's really a very interesting read in terms of trying to understand quantum mechanics and the implications in terms of faith. So this experiment is been done, over 100 times, I'm sure, and it shows the dual nature of light. And you can do it with molecules, you can do it with other particles, so if we look at quantum physics, one of the things that was proposed by Werner Heisenberg, I think it was around 1925. You're looking at something that's about 100 years old, or a little more than 100 years old. It started with work Einstein did again in 1905. The Heisenberg uncertainty principle describes indeterminacy. And it basically says you cannot know a particle's position and its momentum. Now, I'm sitting here, and I know I'm not moving, and I know where I'm sitting. So I know my position, and I know my momentum relative to the Earth. At the microscopic level, you can't know both of those things. It's theoretically impossible to know both the position and the momentum, say, of an electron. And the more you know its position, the less you know about its momentum or speed. And there's no way that you can measure it. Just like when we tried to measure the light, it changed its spots over there in the last slide. Now, quantum indeterminacy basically says the quantum world is fundamentally probabilistic and not deterministic. If I were to take let's say a baseball and throw it up, and if I know the force I put on it and whatnot, I can calculate the trajectory of the baseball. Or we can put a man on the moon. We can calculate, the rocket's trajectory and blah blah blah, what it takes. You can't do that in the quantum world. It's probabilistic. So it would be like saying, we're going to shoot your rocket up to the moon, but we've only got an 80% chance that it's going to get there. Nothing is 100%. And I believe that this provides a physical basis for free will. There's another book I'll mention here that was written by Stephen Barr, who's a physicist at Delaware and very knowledgeable on quantum mechanics. And he's got several chapters on quantum mechanics and free will in the book. It's a great read. But quantum indeterminacy provides a physical basis for free will. Now, what do I mean by that? If our microscopic world was deterministic, let me take this off, then if we wanted to do something different, in order to do it, we'd have to violate the laws of physics, because there'd be no opportunity to do anything else. We're going to go down just one path. That's it. And if you don't want to go down that path, then the only thing you would be able to do would be to violate the physical laws that we're applying. On the other hand, if the microscopic world is probabilistic, then there's no one path that you have to go down. You can choose one. And so I believe that this aspect of our world, quantum indeterminacy, provides a basis for free will. And this was discussed by Miller in his book, Finding Darwin's God. And he gives an example that involves how evolution would go forward. DNA copying occurs on a microscopic scale. There are basically four molecules in the DNA code, and there can be copying errors. There can be errors due to radiation, for example, and these can cause mutations. So the copying is not perfect. So here you have a situation where microscopic effects or quantum effects can then have changes, or can cause changes. There's a corollary to this, and a lot of people will say everything happens for a reason. And if you look at it and you look at the fact that the microscopic world is probabilistic, everything doesn't happen for a reason. And so I think that, I just don't believe that everything happens for a reason, but it's kind of comforting people, if they're faced with something like cancer, for example, they can say, well, everything happens for a reason. No, it doesn't, in my opinion. So now, I started out to try to understand natural evil disease, earthquakes. Why do these things exist? And I've come to the conclusion that, we live in a universe where we're free. Freedom is the greatest thing I think that we have, free will. And it's built into the fabric of our universe at the macro scale and the micro scale, or the quantum level. I think that the universe's design, I would say, is essentially autonomous. And what do I mean by that? I think that God fine-tuned the parameters of the universe so that it would develop in a way that we would eventually get an Earth and a sun and the opportunity for intelligent life. I think the same thing is true with our solar system. I think evolution has patterns in it that are not random. And to me, it says that these areas of science, these were set up so that God did not have to constantly intervene in order to make changes. Now, when I say essentially autonomous, I think that there are rare occasions where I believe that God does intervene. And I have 2 chapters on miracles that I talk about. But I think they have to be rare. I think if every time we got into a problem and we didn't know what to do, we just say, okay, God, solve this for us, we really wouldn't be free, in my opinion. So I think that the miracles happen, but they're rare. And basically, our universe is designed to be autonomous, in my opinion. So, for example, DNA copying errors, which Miller talks about. This is the mechanism for evolution, a mechanism for evolution to advance. And what can happen is that if you get a mutation in a gene, you got, at least 2 possibilities. One, it can be an advantageous mutation that helps with survival. And if that's the case, it's going to be passed on and it's going to be great. And that's how superior traits evolve in evolution. On the other hand, you can get a mutation that leads to cancer, and it's going to be, obviously a bad result. So if you have a mechanism for evolution that involves DNA, then you have this trade-off as a possibility. And I mentioned tsunamis earlier, and the one that happened right after my first wife passed away, where so many people died in Southeast Asia there, something like 180,000. The tsunami resulted from an earthquake. It was an undersea earthquake. And there's a trade-off there that if we didn't have plate tectonics, then there'd be water all over the earth. There'd be no life. So if we want life and we want water, obviously, then one way to get it would be to have plate tectonics. But if you have that and you have a molten core, you're going to have the possibility of having a tsunami. So there's a trade-off there as well. And I think that the universe involves trade-offs. So let me, I've only got 2 more slides and then we can discuss. I have 2 chapters on miracles. And I like to think of miracle as data in quotes for faith. And why do I put data in quotes? If I were to run an experiment, a scientific experiment, I'll make replicate runs. So I will, take a set of data, take another set of data, and then analyze the data and try to come up with some way of modeling it or whatnot. With a miracle, they're one-off events. As far as I know, you don't see, exact duplicates of miracles. Even in the Gospels, I think you find out or you see that there are differences. There was one, I don't know, a couple of weeks ago where Jesus, I think, spit and made mud, and he may have put it on the, I know it was the eyes of the person that was blind. So we have one-off events that are not duplicated with miracles. But the thing that we have is we have facts that we can verify. So the miracles that I've talked about in the book, there are 5 of them. I talk about miracles from Lourdes, the Shroud of Turin, which I've been looking at now for probably 7 or 8 years and published several papers on. We've got the recent miracles, Eucharistic miracles with the hosts that have occurred in South America and in Poland. We've got Our Lady of Guadalupe, Juan Diego's Tilma. So that's something that can be looked at or analyzed. And we've got Fatima. So let me just quickly talk about one, and then I'll end. And this was a miracle that took place in just about 100 years ago. Jack Traynor. Traynor was a Brit from Liverpool. He's shown here in the wheelchair. He was wounded in World War I. He lost the use of his right arm. He had something like 4 surgeries trying to restore the nerves. None were successful. He also had an earlier wound that caused epilepsy. And he was an absolute mess in 1923. And it's interesting that his parish priest was pleading with him not to go to Lourdes. He said, "Don't go, it's going to kill you." He was dirt poor. He had to scrape together 13 pounds in order to make the trip. And it caused kind of a stir. And this picture was taken of him on the train station when he was heading off to Lourdes. He went to Lourdes. He actually visited the baths 9 times and was cured. And here's a, whoops, wrong one, pressed the wrong thing. Whoops. Here's a picture of him coming home. He's wheeling the wheelchair. And these are taken from the Liverpool newspaper, the Echo. And he had use of his right arm. He actually had a hole that they had operated on in his head and put a plate in, and that was closing up. And everything that was wrong with him was essentially solved. And this is about something like 10 days later. The medical records are available. Doctors have testified that there's no way to explain what happened to him. So these are the kinds of things that, I've tried to look at, where there are physical facts, documentation as to what happened. And as I say, I think that these do happen. I think they have to be rare. Otherwise, every time we got into a problem, we'd say, I need a miracle. And that's not going to happen. So that's all I was going to do. I was going to just put this up as a last slide. The book was published in mid-February, and it's available at the publisher, Whiffenstock, and at Amazon. And I put my email here if anybody has any questions or wants to comment or contact me. And so with that, let me stop, and we can answer any questions.
All right. Thank you so much for that presentation, guys. I know it went a little long, and we did jump in. We weren't supposed to, but we did.
No, that's fine. I'm glad you did.
But it's okay. Tyler actually had to bounce out. He has a date night, so
okay.
We're gonna start with the questions. Dale, I'll give you the first question since I know you had some that you wanted to follow up on. So go for it, buddy.
So you're talking about like the one about the solar system way back in the
yeah.
Okay, so I have 2 questions, and then I'll give it to David because I know he's probably going to want to grill you, get your opinion on the problem of evil stuff. But so with the solar system, I was just going to raise a couple questions, like the naturalists and the skeptics and stuff. They'll give the nebular hypothesis or something. So I just wanted to get your take on the the natural alternatives. Do you think that these even come close to trying to explain the fine tuning we see in the solar system? Or?
Well, I think that there may well be other parts of our universe that have similar environments to what we have on Earth. But if you look out and you say, okay, what is it going to take to have the kind of life that we have here on Earth? Our sun is I think it's an orange dwarf, and they're only about 7% of the stars in the universe. Most of them are red dwarfs, and they burn forever, but they are not as hot as our sun. So a planet would have to be closer to them, and then you get into issues if the planet is tidally locked as it rotates around that star. And there are a lot of reasons that red dwarfs would not be very conducive. The planets around them would not be conducive to having intelligent life. So you need to look at all of these things. And are there going to be some places where they have conditions like we have on Earth? Absolutely, I think there will be some. I think they will be few and far between. And it's not as finely tuned as the physical constants were for the Big Bang. But just to simply say, with the millions of stars out there and the millions of planets, there's bound to be intelligent life. And that's why that book that I put up, it's called Rare Earth. That they think it's going to be rare, and they actually went through. There was a calculation that was done. What's the probability? And they redid it, and it's pretty damn small. So. But I don't know if that answers your question, Dale.
Yeah, no, that's great. Okay, and this will be my last question, and I'll give it over to David. This is on the creation evolution debate, because you mentioned Ken Miller and his kind of refutation of Behe's intelligent design argument and stuff. So I did have Michael Behe on my show, and he responded to Ken Miller. So I want to play like a 3 to 4 minute clip, if that's okay with David, and then get your kind of response to Behe.
Okay, and what is he, a proponent of intelligent design?
So Michael Behe, he goes for irreducible complexity, the bacterial flagellum, and then
yes, okay, that's one of the irreducibly complex examples that they throw out.
Yeah, and Ken Miller counters that with the co-option thesis, the mousetrap. So I asked Michael Behe, what does he think of Ken Miller? So that's what I want to show you.
He probably doesn't like him.
Oh, he disagrees. I'm on Behe's side myself, but I want to get your take to Behe's response. So it's just a 3 to 4 minute. All right. So
Ken Miller, who's a
are you hearing that?
I can hear it.
Biology professor at the university, said, "Well, hey, look, this type 3 secretory system, this needle, this pump, it's called the type 3 secretory system. Maybe that's a simpler, it's a simpler machine than the flagellum. So the flagellum is not irreducibly complex, they'd say, and maybe this apparatus could be turned into a flagellum." So here we have a wonderful example of an evolutionary intermediate that shows these claims of irreducible complexity to be wrong. And you say to yourself, well, exactly how does that show it? Because nobody explained where this type 3 secretory system, this needle complex, came from. Nobody shows how it could be turned into a rotary motor. Nobody has shown anything except to say, here's this other structure that uses components similar to these found here. And so we will assume that one is related to the other by random mutation and natural selection. In fact, if you look at the type 3 a secretory system, it doesn't have the ability to turn a rotor. It doesn't have the ability to turn a propeller. What small steps would you take to build that thing. The function of pumping proteins into another cell has absolutely nothing to do with the function of a rotary propulsion. It's like saying, well, we found this washing machine that has, some semblance of or some resemblance to this other thing. So therefore, the washing machine was probably a precursor to a flagellum, but the washing machines have nothing to do with rotary. Well, they do actually. But anyway, I guess the main point is that the invocation of co-option is not an explanation. It's simply a observation that one thing looks like another, and it doesn't explain at all how the one thing turned into the other, or the other thing turned into the first one, or they arose independently, or any such thing.
Okay, so this is one of the examples that Miller talks about. I haven't read the flagellum part of his book in a while, but just a couple of comments. One of the things that Miller talks about is that you can get gene duplications, so that a gene can be copied, and you wind up with two copies of it. And this is one of the ways that evolution advances. And all of a sudden now, that second copy can be freed up to do something differently. And he's got a great explanation of blood clotting, which is another example that Bay uses, that he says, okay, blood clotting involves an enzyme cascade. There are 13 steps. You take one of them out, like a hemophiliac, and they're going to die because their blood will not clot. So they get a little cut and they bleed to death. And he proposes a very reasonable way that that whole sequence could have evolved given enough time. I have a counterexample to what Professor Bay is talking about, and that involves vitamin C. We have a gene, humans have a gene that to produce vitamin C, except it's been deactivated. So we don't produce vitamin C, we have to get it in our diet. So if there was, quote, an intelligent designer that was designing all of these things, why would the designer design a gene and then turn it off? That doesn't seem to make much sense. It doesn't look very intelligent in terms of what Bay would say. And the last point I'd make is that with intelligent design, the problem with it is you can't test it at all. There's no way to test it scientifically. It's just like the people that say, with the multiverse, that there's no way to measure these other universes. So if you get to a point where you can't explain something, then if you invoke God must have done it, that's not science, that's faith. So they should call it intelligent faith or something like that, but it's not science. And, so those would be the answers I would give. That it'd be interesting if you got, Ken Miller on to talk about some of the examples. And when you're dealing with complex biology, which obviously we have in our bodies and animals have, it's pretty easy to find something and say, oh, well, explain that. And it might take years and years of research to figure out, like the blood clotting example or the flagellum. And so you can come up with a lot of examples and just say there's no way to explain this. And my bet would be that the evolution people are going to be able to explain those questions. So
all right, awesome.
That's my bias.
Yeah, no, thank you so much for your response to that. So over to Mr. Russell. I know he's dying.
No, I'm fine. This has been very interesting so far. I do have some questions because I'm a philosopher and I'm also a theologian. So,
Okay.
I've read a big portion of your book. I haven't been able to finish it, but I got as much as I could. I did buy it, and I like doing that because I like to show my guests that, hey, look, if you produce something that's of significance that you think people need to read, before you come on the show, I at least need to be familiar with it, and I think that's
Oh,
fair.
that's nice.
But you did talk about, I want to know your reflections upon Genesis versus your science, right? I do want to kind of, you kind of explain how you view Genesis, and in light of, your idea of the book of nature.
Okay. I think Genesis contains accurate theology. God created the universe. But I think that what Genesis is stories that came down through the ages. And I don't think you can use Genesis. I don't think Genesis is science. Let me put it that way. For example, the days of creation. If you read that, the sun and the moon were created after the earth was created, and the sun is actually a little bit older than the earth. And at the end of that story, the days of creation, there's a statement, something to the effect that I'll give you all the it's like vegetables or green plants to eat, kind of implying that man was not supposed to be a carnivore, and yet, or that life wasn't supposed to involve carnivores, and yet, you look at Tyrannosaurus Rex and whatnot, there were a lot of carnivores running around before we came on the planet. In the Adam and Eve story, you have the same thing where, because of the fall, weeds and trouble working the earth and pain in childbirth came into the world. Well, I think they were in there from the beginning. And I think that one of the problems that the writers had was trying to explain how a loving God could have a creation that involved things like, animals killing one another, or weeds, or other problems that existed. So I think they're stories, but I think they contain accurate they contain accurate theology. So that would be my answer.
So I wanted to know your thoughts on this because, from what we understand from Genesis is that there is historical narrative going on there. And it's not simply poetry or anything like that. And Helen Fryman, a Hebrew scholar, says the normal order for a Hebrew narrative sentence is conjunction, verb, subject, object, right? Versus like poetic stuff or things that are fiction, which are subject, verb, and object. What do you think about Genesis as being historical? Because I'm not sure if you're familiar with Hugh Ross's work and the Reasons to Believe crew, but they do extensive work on how, they agree, Genesis isn't science. We have two books. We have the book of nature and the book of scripture. But there are really distinct parallels in the creation days that actually corroborate what science says on the earth. Like, we miss the fact that, God uses a Hebrew, or, the Bible uses a Hebrew merism when it talks about, God says, let there be light. It's not talking about, that's not like, or he says, that comes later. My fault. I misspoke. But when he says God created the heavens and the earth, he's talking about all of reality, and includes like, the idea of a 13 billion years. It's, he's going off those models. He's obviously firm believer. He's an astrophysicist in the Big Bang. And my thing is, if it's given us historical narrative, isn't that something that we should be looking more into and put that in kind of the forefront when we're examining these type of issues?
I think that would be interesting to look at. My own kind of biases, I don't think that I think that the creation stories came from the Jews who believed in their God. They had an experience to lead them to believe in their God, and they were trying to explain the world that they saw. Now, I don't think they had any scientific insights. And I think that we've learned so much more about, how the universe started. And I don't want to read too much into what I read in Genesis 1 or Genesis 3. But I firmly believe, that God created the universe. And but I think that they were stories, and I don't think that you can talk about them being historical. Would be my opinion.
Okay. So, like, what would you? I know you make the strong case for evolution in your book, but you what Scripture seems to indicate that man's a special creation made separate from other life forms. It doesn't include it with the other life forms, but separate from that.
Mhm.
So if the Scripture does tell us this and science tells us this, what do you go with?
I think you can have your cake and eat it there. That I think that, for example, we share, 98 or 99% of the genes of chimpanzees and bonobos, I guess they are. We're the same in terms of that. I think what happened is that evolution got to a point where pre-man was capable of getting a soul. And when that happened, then God created humans at that point. And so I think you can combine evolution with Christian belief, and there's no problem with that. I don't think there was a separate creation of man because, for example, the genetics that we share with other animals. I think we evolved from other animals, but we got to a point where we were capable of having consciousness and a conscience. And I think that's when the human race started. So I don't think it has to be either or. I think you can have what you're talking about as well as have evolution. And to me, that would combine the science and the faith.
Right on, right on. Dale, I'm going to give it to you. I just asked 3 questions basically, so I do want to give it up to you as well as we get into more, because I know we're going to get into natural evil here soon. So,
Okay. So question 8, I think, is what you're on, right, David?
yeah, we just did question 8.
Or okay. Okay, so in the chapter concerning intelligent design, you said it is not logical that God would reveal himself through miracles, but instead he would stay hidden in intelligent design. So we just want to know, like, what in the first, what law of logic are you trying to say that God doing miracles in this way would violate? And if God had a practical purpose to intervene in these specific situations and not in others, what do you find to be illogical about that?
Yeah, that maybe the logical is probably the wrong choice of a word. I think that what I see is that our universe was designed to be, as I said, almost or essentially autonomous. That the universe would expand, stars would form, planets would form. I think the same thing, you see patterns in evolution and I don't, one can ask the question, if as the intelligent design guys want, they want God to be intervening here, there, and everywhere. And I think, to me, it's maybe simpler to say, instead of saying logical as the adjective, that God just set up the universe to go forward and eventually get to a point where he could give humans a soul and get to, I think, intelligent life was the objective of the whole thing. And I do believe that he does intervene through miracles, but I believe that they're rare. I don't think that you're going to have as much intervention as the intelligent design guys want. But basically, they're just saying on faith that, when they can't explain something, then God did it. I think you make a fair comment about the wording about it being violating logic. I think it's just, to me, simpler to say the system was set up in such a way that it would move forward. God has the ability to intervene. He does occasionally and rarely. But it's up to us. We've got the freedom and the intelligence to solve problems. And I think that, to me, that's one of the greatest gifts that we have. That every time that we ran into a problem, we said, okay, God, solve this one. I mean, for example, with the mutations that occur and cause cancer, why didn't God solve that? If he's doing the flagellum, or if he's doing blood clotting, why let the mutation go forward so that somebody's going to get a cancer? So you make a good point, though.
Okay. And I guess one last question before we go into the quantum, the other question on free wills and stuff like that. So I hear what you're saying and stuff like that. We want to avoid a lazy God of the gaps type reasoning and stuff like that. At the same time, we don't want to dismiss God as a designer in certain events, such as miracles and stuff. So,
right.
How would you say we would? Well, in the case of, do you think that there could be reasonable inferences to design in the field of biology or anything like that? Like, could we, if we aren't just relying on a lazy, well, I'm a religious person, so God of the gaps, is there a place within science to make a design inference in that field?
Yeah, I tried to write the book from a design perspective, from an engineering perspective. And as an engineer, whenever you design anything, you're going to have trade-offs. It's inherent in the design. I use the example of an automobile in the beginning of the book. If you wanted an automobile that people wouldn't die when there's a crash, basically build tanks and let people drive around in tanks, and we'd save a lot of lives. On the other hand, the tanks would be unbelievably expensive, and to operate and to buy, and so you have trade-offs. And I think that when I look at what I see in the universe, I see these trade-offs. I see it in genetic mutations. I see it in the fact that you get tsunamis because of plate tectonics. And so to me, the freedom that is been built into the world results in these trade-offs. And that's a design component. Whereas the intelligent design guys are saying, they're going along, and then all of a sudden they can't explain something. Oh, well, God did that. And it's God in the gaps. But I think there is a definite pattern that you see if you look at the fine tuning of the universe, the constants of the universe. If you look at evolution, you see patterns. So to me, yes, there is definitely a design of our world. And, to me, it's a pretty amazing design. I think the fact that we have, on the macroscopic scale, a deterministic type universe that we deal with every day, and yet on the microscopic scale, it's probabilistic. That, to me, is an unbelievably creative design.
You said this, and I have to bring it up because I think I need clarification as well. And you're kind of alluding to it in some ways when you're talking about the probabilistic and stuff like that. This is obviously has to do with the free will and sovereignty of God, and the providence of God. You said earlier, and you allude to this in your book, that this idea of trade-offs and this idea of nothing happen, or some things they just don't happen for a reason. So what does this have to say for God's omniscience when we see scriptures that say he knows the end from the beginning? So how do you deal with the foreknowledge aspect? Or are you an open theist on this?
I think if you look at the probability of something happening, and if we really have free will, there is not one path that life has to go down. You can't predict the future. in my opinion.
Okay.
I can make a choice that can affect the future.
Right.
You can, Dale can. So I don't think there's one particular path, there's one outcome. You had mentioned in one of the things you said about the Calvinistic idea that everything's predetermined. I don't think that's true. And so I don't think that necessarily disagrees with the idea that God is omnipotent and knows everything. I think he gives us a lot of rope and respects our freedom and doesn't impose his will on us.
But does he know? But does he know the end? Does he know the beginning from the end?
I think he would know the probabilities. But if there's more than one way that things can evolve or can go forward, I don't see how you can say there's only one end. There's, if you look backwards, you can see that there's one end. But when going forward, I think there are many different things that can happen.
Yeah. And he would know. He would actually know all those ends that would possibly happen because he would know all possible worlds.
Probably,
right? Yeah.
Probably, yeah. He definitely would know them. And then the question is, if I, as an individual, happen to pick one that's highly unlikely because of my free will, that's going to affect the outcome,
Okay.
in a highly unlikely way.
Dale,
But I would certainly know the probabilities of these things happening.
All right, Dale, you want to follow up on that?
Yeah, just a very quick question. This was something I wish I had asked you about when I had you on my show and we were talking about this. So you mentioned that free will for you is grounded in quantum indeterminacy. And I just wanted to get that, as a philosopher, there is a difference between, a stochastic, randomness that, is in quantum indeterminacy versus free will, which is really grounded in the agent as being the prime mover. It's not a random probability.
Right.
So there's a difference there. So why do you equate them, kind of thing?
I'm not equating them. I'm saying that what happens is if you have a world that is probabilistic, that gives you sort of a basis where then people can make decisions, can use their free will. If you had a world that was completely deterministic, the only way I could express my free will would be to violate the laws of physics. But if there is no one path that has to occur, if there's multiple possibilities, then I can make a decision as to which one I take. Now, how my free will actually gets to the point where the decision is made, I think people have to study that a lot more. But fundamentally, you can see a difference between a world that is completely deterministic, so there's no possibility without violating the laws of physics to change anything, versus one that's probabilistic, where there's no set outcome. And if you have that as your fundamental basis, it gives you then the possibility of making decisions freely. And I think that's the difference. So I'm not equating quantum mechanics, which is probabilistic, with your ability to make decisions, which certainly isn't random. If it were random, we'd be in a real mess. It's logical, and it's based on your conscious thinking about it. I don't know if that answers, or it's clear enough, answers your question.
Yeah, no, that was great. Yeah,
They're two different things. One is, it's just the physical basis. If you have two different worlds, one's deterministic and one's probabilistic, how do you change the deterministic one? If you decide you want to do something that, if it's completely deterministic, you don't have any free will. You just have to go down that path. That's it. And the only way that you could not do that is to violate the laws of physics. If it's probabilistic, you've got a whole smorgasbord of choices that you can make, and none of them violate the fundamental laws of the world that you're living in.
Gotcha.
So it's the basis for free will, the physical basis.
Gotcha.
This book by Stephen Barr, he has probably 5 or 6 chapters quantum mechanics and the mind and deterministic systems. It's a fascinating read. I don't know how well it's sold, but it's really interesting in terms of his perspective on it.
Awesome. Okay. All right. Cool. So, I guess I'll just ask question 12. Like, what are some of the ways that you think the church now can intensify its efforts in terms of examining how God interacts with nature and looking at God and science, as a church?
That's a great question. I think that I don't think the church has really fully come to grips with modern science. There are very few people in the church probably that really understand things like quantum mechanics and evolution and whatnot. We had a priest here in our parish a few years ago, and he honestly believed that before Adam and Eve ate the apple, there was no death in the world. And I just could not accept that, but he believed that, and that just to me disagrees with everything that we know from evolution and whatnot. So I think we need people that understand the science, are not antagonistic towards it. And Spitzer is maybe unique in his knowledge of physics and philosophy and theology. And it's going to take a while before these concepts are looked at. I mean, my book, I think, really, if anything, scratches the surface. I don't know, for example, when I make a free decision, I can't tell you how that decision is made and how the neurons in my brain are implementing the decision. And there's just a lot of research that needs to be done. But I think one of the key things there is that you can distinguish between probabilistic and deterministic, and that sort of stuff I think has to be worked into theology. And the church shouldn't be afraid of science. Another example that I know you're interested in, the shroud. I think it's a crime that the church is so afraid that if additional testing on the shroud were done, it would show that it's a medieval forgery, that they just are in the foxhole about it. And they're afraid of honest scientific inquiry on it. And that's not good. Unfortunately, the church moves at a very slow pace, and it's going to take a long time before they really fully integrate the knowledge. But the great thing to me about the Big Bang is it completely agrees with what's in the Old Testament. I have a section at the very end on original sin. So you have, in the Old Testament, they ate the apple and that's it. I think that what happened with original sin is that once man got to the point where they deserved the soul, once pre-humans, and we became human, then we became aware of our actions and the effect that they caused on other animals and other people. And if we then made the decision to cause harm, I think that's the source of original sin. So I think you can come up with an explanation for that type of thing, looking at evolution and looking at the science. But it's going to take a long time.
I'm going to jump into just complimenting you that, I think one thing we miss, and I think you bring this out, and which I agree with when it comes to your whole idea of natural evil and stuff, is we need, as a church, a theology of ecology, right? We need to understand how it relates to what the scriptures tell us, because I do think it is historical. I think there's historical narrative in Genesis, and I don't think we can deny that, especially when we start looking into the culture and exegete the scriptures properly, right? There is something to say about we need to understand the scriptures the way they're written at the time they're written and who they're written to, and you know, things like that. So I think we need a proper exegesis, and I think a lot of these myths go away, like Adam and Eve eating the apple, and that's it. No, I don't think so. And some people thinking that death wasn't in the world beforehand, I think that's a myth too. I think that when we look at the scripture and we see that when it says death into the world, I put this up earlier, by one man that death entered the world. When you break that down, it's talking about the world of men. You know, it's not talking about the world in general. And for God to create a reality that we live in today, he would have had to have created an ecology for these beings to be able to create an equilibrium, right? And that comes through carnivores. They do wonders for the ecology, you know, on the ecosystem. So I don't think that was a bad thing. I don't think we have to fear what we see in science on that, because I think it could still be a good creation with those things happening. Because I don't believe this is a little nuance. I don't believe in natural evil, like you said in your book.
That's natural evil is the wrong term. It's nature,
Yeah.
I think.
Yeah, and that's the thing. You know, I think the bad thing is when it comes to a tsunami, for example, is that people have to die in general. I do think God put us in a garden, a real garden, and that garden was a mercy, even because I think there were two ways that we could have understood things, and that was through the innocence path. I think mankind was innocent, and he put us in the garden to try to experience that. However, we chose the hard way, which makes Jesus always the plan A. God knew it was going to happen beforehand, you know. So that's where we kind of differ on in our theology here. But what scares me in your part of hold on one second, guys.
The dogs making a
Yeah, they're just going off. We just had the doorbell ring too, so that's what they're responding to. But this idea of trade-offs, and you said something in your book, and I need clarification on it, because for me it's very important. You said good and evil are inherent in the creator's design. Now, I can understand the potential of evil being there, but I don't think God created evil inherent. So
again, the wording is a little flaky. I don't mean to say that God created evil. I think God created a universe where there are trade-offs, and some of the trade-offs can lead to cancer or disease or things like that. And it's just part of the design that you can't, I don't think the world is designed to be perfect because it's a physical world.
Right.
Myself, I think.
Well, it's finite. You know, I mean, you know, there's only one perfect, and that's God, right? I mean, perfection is something that is beyond the finite. You know, so I agree with you there, and I'm glad you cleared that up. For me, I think that once we fell, I do think there was a real fall, right? And I think once we did, we became suspect to those to that nature, right? And we're still supposed to dominate it. We're still supposed to dominate it, but it's going to be a lot harder now, you know. So
there's one example that I gave in the last chapter that I picked up, and it's interesting. It's the nations in Africa where the slave trade was particularly fierce, and you had, relatives actually turning relatives in for slaves. They're actually doing poorer today in terms of their economy than neighboring countries where this didn't happen. And it's just the fact that people don't trust one another because of that experience. And something like that can very quickly affect the way that people behave. And I think that that's probably what happened with original sin, that we had the freedom to go down the good path or the bad path. And once we went down the wrong path, I think it had profound effects rather quickly, and more quickly than, say, the evolutionary time scale. So I agree with what you're basically saying there.
Yeah. And, that's part of my thesis is I'm trying to incorporate a theology of ecology into my paper to say, hey,
It
look.
sounds like it's be an interesting thesis.
So, yeah, I'm going to try. But thank you for clearing everything up. I just want to ask one more time because you covered it in
Sure.
the beginning. But I want you to cover it again because we're at the end here.
Yep.
I want to say overall, what is the biggest thing you want others to take away from your book?
Okay, 2 points. One is I really believe that the church and believers don't have to be afraid of science, particularly modern science. And, the more you look at it, as Gillen has done brilliantly in his book, the more it agrees with what we find in the Gospels and in the Bible. So I would, that would be one point. And the other point is that I think that I believe that the greatest gift we have is freedom. That to me, everything that I look at suggests that, the fact that we're free, we can make decisions, we have this marvelous basis for making decisions that's based on quantum mechanics, to me is fascinating. That whoever, God, designed this system so that we live in basically a deterministic macro world and a probabilistic micro world. I mean, what a genius design that is in terms of allowing us to express our free will. And I think more work needs to be done to try to appreciate that. And so.
Dale, I'm going to give it to you. Do any last minute questions or anything you want to add in or whatever?
I think, guys, like in terms of the list, I think we covered all the major topics. I think you covered the problem of evil topic really pretty well and stuff. So yeah, I'm kind of struggling to think of a follow up. Well, okay, here's one. Okay, so because of the role of free will, and as I understand, I am on your side in rejecting a deterministic universe or something like that. At least in terms of denying libertarian free will agents play a role and they're non-determined. But there is also this sense in the Bible that look at everything that happens is part of God's plan, and it's guaranteed, not determined maybe, but guaranteed to arrive at that end goal that God's got in mind there. So yeah, like what would you say? How can he say he's guaranteeing something if it's only he's playing the probabilities or something like that, and there's a chance that it might not turn out like he wants it.
I think if if you're saying it's guaranteed in the sense that we don't have a choice, I don't see that as really being in the scriptures. To me, I think we have free will. I think God created us that way, and I think that He gives us space to do that. Now I do believe that while I said that physical miracles I think are very rare, I think there's constant spiritual insight that you get from the Lord, so I think that as long as we have free will, then I'm happy with that. But if you're saying basically that God's going to determine everything and we don't have any free will, I mean, I just can't accept that.
Yeah, and there's other views out there too. We got Molinism, we've got Arminianism, we've got the whole theological thing. They've been debating that for 2,000 years almost. So, but I do want to say this is love can't exist without freedom. So I do believe that, and that's I think is a real strong point. But go ahead, Dale. I know you had something to follow up.
No, I was just going to say, like, yeah, okay. So I think, yeah, you kind of equate guaranteeing as meaning determined and stuff like that, whereas I was trying to make a distinction between those, where I think the word guaranteed can include libertarian free will. Like, it's guaranteed, given God knows in advance what each libertarian free will agent will freely choose. to do in any circumstances, and then he uses that knowledge to guarantee that the end result will come about at the end of time, type thing. So yeah, that's what I was asking. But you kind of equate like guaranteeing is the same as determining type thing. So is that right?
Yeah. I guess I'm worn out from all the discussion.
It's all right. It happens. But we really thank you for being here tonight.
Well, it was great discussion, great show. I'm very pleased to have participated.
Yeah. And we'd like to have you on maybe again just to talk about more of these type of things,
Sure.
And we could do a general conversation instead of just working off slides. I know that was a big part, and that wears you out too. It's like teaching a class and then having to deal with an interview afterwards. It's crazy.
I haven't done that for 20 years, but
but hey, again, I enjoyed what I've been reading with the book. You allude to a lot of stuff that I think needs to be understood as well. But I think we can solve it with a theology, and I would encourage you also to look at Hugh Ross's stuff, Reasons to Believe. He actually he has a video out called The Journey Towards Creation that is really good. It's still relevant for the day, even though some things have been updated, but I think you'll enjoy that too. But guys, Dale, what's going on Real Seekers coming up, man?
Yeah, so next week, I'm going to be doing a show with Tyler Fowler with the psychic Barbara With, who, interestingly enough, claims to channel Albert Einstein. So she's got a bunch of knowledge from him and stuff like that. So yeah, we're going to be talking to her about what her beliefs are, and also probing a bit and trying to challenge it from a Christian perspective, and see what she makes on that front. And another show I'll just announce since it's appropriate. I'm going to be having Dr. Tom McAvoy as one of my panelists on April 12th, where we're going to be alongside Michael Kowalski, Joe Marino, and Jordan, who's the atheist co-host of the Reason to Doubt podcast. And we're going to be discussing the carbon-14 dating of the shroud, just that one topic. So we're going to be going into it in a lot of detail and stuff. So yeah.
That's very fascinating.
Looking forward to that.
So guys, I am putting the link down at the bottom here so that you could get God the Geometer today on Amazon and read it yourself. Enjoy it. Dr. McAvoy, is there anything else you want to say before we jump off the air?
No, thank you very much for inviting me, and I'm looking forward to Dale's podcast in April.
Just wanted to say we got a good comment for you before we go out from Kamazine. Thank you and God bless. I appreciate that Dr. McAvoy broke down difficult concepts to a more understandable level. So there's some audience appreciation. That's always good.
Yeah.
Right on. Okay, guys. Well, until next time, as Tyler says, God bless. Good night. God bless. And stay like Christ. Enjoy your night, guys.